1, 2. All right. So let's solve some linear equations. Linear equation just means that you do not have exponents on the variable. That's what the linear part means. It's is no exponents on the variable. So when we get a couple of weeks from now, or about 4 weeks from now, we're going to be doing things that have exponents involved. Things we're doing right now don't have exponents involved in when we're solving. So it's going to be simple, straightforward calculations and solving equations. So the goal of solving equations is get the variable by itself. So isolate the variable. So we got to use inverse operations. So if they're adding, the opposite of addition is subtraction. If they're subtracting, the opposite of subtraction is addition. Okay. If they're multiplying, we're going to do what? Divide. If they're dividing, we're going to multiply. Those are the things we're going to do. Okay. So we're going to do the inverse operations to get the variable by itself. So we'll kind of increase in difficulty as we go here and get to some that are much more interesting than the ones that we're doing here at the beginning. But baby steps to get there. Okay, so example A there, x plus 7 is equal to -3. So we look at that and we see which side's too heavy, which one has too much stuff. Where's the variable? So on the left side, you got x plus 7. On the right side, you just got a -3. So the left side has too much stuff. The letter's over there. So we want to get rid of the things that are not the variable. So they're adding 7. The inverse of that would be subtracting 7. And with equations, whatever you do to one side, you got to do the exact same thing to the other side. So we're subtracting 7 from both sides of the equation. What happens is these 7s on the left side cancel each other out, and that leaves us just x. And then we have this math problem, -3 minus 7. -3 minus 7 makes -10. And we get the answer for x. We get x isolated, nothing else with the x, and we're done. We can check that by taking -10 and plugging it back into the original problem. -10 plus 7 is -3. It checks. That's the right answer for that. So anytime you're working equations and you get a solution, you can check to make sure it's correct by plugging it back into the original and working out those sides to make sure they're equal to one another. Okay. Go to the right there. Example B, we got 2x is equal to 18. When they mash them together like that, what's going on between the 2 and the x? They're multiplying. So I always mash them together, they're multiplying. So 2 times x is what that says. So to undo that, we're going to do what? Divide by the number that they're multiplying by. So we're going to divide by 2. We're not dividing by 2x. That's a pretty common mistake folks make, is they try to divide by the variable 2. But you're dividing by the number only. And then, does 2 go into 18 evenly? Yes, it does. How many times? 9. If it does not go evenly, you're just going to reduce that fraction. So like if it were 18 over 4, 4 doesn't go evenly, you would reduce it to 9 over 2. So we'll just reduce the fraction if it doesn't go evenly. We'll kind of see that as we go along here. We'll see some that don't go evenly. Okay. All right. C, we got 2x plus 7 is equal to -5. So this one's a lot like example A, except for we got something else on the variable here. So we want to, again, get the variable by itself. So that entails moving things that don't have a variable first. So on that side, 2x plus 7, what needs to move first? The 7. How are we going to move it? Subtract it. The opposite of addition is subtraction. So we're going to subtract 7 from both sides. There's 2x is equal to what's -5 minus 7. -12. And then one last step to get x by itself. Divide by that 2 that's on the variable. They cancel each other out. -12 divided by 2, -6. Be careful about your signs. A very common mistake to miss a sign there. Most common mistake in math classes from 7th grade math all the way through calculus 3 or differential equations. You miss a sign, it's going to mess up the problem. Okay? All right. Example D, we kind of step it up a little bit. We've got variable on both sides of the equation and plain numbers on both sides. And so we've got to make a choice as to what to do. It doesn't matter what choice you make for the first step, but your choice for step one is going to affect your choice for step two. Okay? So I'm one of those people that I like to get my variables together first. And so that means I'm either going to have to move 3x or I'm going to have to move the 10x. It does not matter which one I move, but I'm going to move one of those. Okay? I think I want to move the 3x. What kind of 3x is this? It's positive. This minus sign right here, a lot of folks think that minus sign goes with the 3x. It does not. It goes with the 7. The sign always goes with the number it's in front of. Okay? It's in front of the 7, so it's a minus 7 there. So we want to move this 3x. If it's positive, in order to move it over to the other side, we're going to have to use what operation? Yeah, subtraction, like a negative 3x, so minus 3x. Positive 3x, minus 3x, what happens to them? They cancel out on that side. That's what we want to happen. That's the reason we're doing that, is to cancel those out. So on the left side, we have negative 7. On the right-hand side, we got 10x minus 3x. That'd be 7x. The 14 is still there, so it's still plus 14. Bless you. And then the right-hand side's too heavy now. It's got the 7x, and it's got a plain number. And negative 7's a regular number, right? So that means I need to move what next? I'm going to move the 14 instead of the 7. I don't want to move this 7 because there's 1 thing over here and 2 here. I want to balance it back out. This side's got too much stuff, so I need to move this 14 over here with the 7 so that I get 1 thing on each side. All right? So how do I move that 14? Subtract it. Minus 14. Those cancel. Negative 7 minus 14. Negative 21. Now I've got a problem where I've got 1 thing on the left side, 1 thing on the right side. I've almost got x by itself. How do I get x by itself? One last move. Divide by 7. Negative 21 divided by positive 7. Negative 3. It goes evenly, so we're going to use negative 3. Equals x. If you turned that around and said x equals negative 3, it's absolutely the same thing. If we had moved the 10x at the very beginning and worked it, we would have worked it correctly, we would have ended up with the exact same answer. It does not matter which direction you go first, as long as you get letters to one side, numbers to the other. It doesn't matter which way you do that, as long as you're doing legal operations and getting like terms together on opposite sides. Let's look at example E. This one's a little bit more complicated. It's got those parentheses in it. What property does this look like over here? Multiplication and what you say, Tristan? Distributive property. That's what it's called. It's multiplication, but it's called distributive property. So we're going to distribute a 3 to both pieces in the parentheses. We're going to multiply both pieces by 3. I'm going to do that first. It's going to give us 6x minus 12. On the right side, I see parentheses as well. What gets distributed over there? So the 7 is here, and then there's a negative 1 in front of those parentheses. It's going to distribute just like the 3 did on the other side. I'm distributing this negative 1 to both of those. So that's going to be negative x minus 5. So it changed the sign of both of those pieces. Now I've got a problem that's got 2 things over here, 3 things over here. Can I simplify the right-hand side? Can I put some of that together? Are there like terms on the right-hand side? Not quite. 7 and -5. What's 7 minus 5? Not -2. 2. So -x plus 2 is what that's going to simplify to be. All right. What now? A couple of options. A lot of options, actually. Yeah, now we're back to one like example D. So we got an option. We move 6x or we move this -x. Technically, we can move the 12 or the 2. It doesn't matter, really. I'm one of those people that likes to move the variable parts first. How could I move this -x? Add x. Good. Add x. So that's going to be 7x minus 12 is equal to 2. And I'm leaving a lot of space here. So I have to leave that much space. All right. So what's next? Add 12. Good. Because we want to get the like terms together. 12 is like the 2. It's a plain number. So we're going to move it over by addition. So that's going to be 7x is equal to 14. And this works out real nice because now, last step, divided by that 7, and x is positive 2. Okay. All right. Distributive property involved there. Let's throw some fractions into the game. I'm going to show you a trick here. How many of you love fractions? What? How many of you hate fractions? I hate them in the math class anyway. I like fractions. If you don't like fractions all together in the whole world, then every time you get change for $1, I'm going to put a bucket in here. You bring me that change. I'll take it. What, man? I know what that. See, that's why I need all the change because I can grab $1. Teach for a living. We don't make any money. So, all right. Now here's how. What I want to help you do is get rid of those fractions so that you don't have to deal with it. Okay. So you just got to have a little bit of number sense to be able to get rid of fractions. What you want to do is look at the denominators. The denominators in this problem are 3, 2, and 3. I need a number that 2 and 3 both go into. 6. Is that the only number? No. There are other numbers that 2 and 3 both go into. 12, 18. You know, those are, but 6 is a good one. It's the smallest one. So that's the one I want to use. It's the smallest one. So what I can do is multiply every piece by 6 so that I only have to work with the fractions this one time, and then I get rid of them. So if I multiply everybody by 6, so this entire problem by 6, what's 2/3 of 6? I don't know, Mr. Isbell. I'm not a math person. So I'm just going to do it. Multiply 2/3 times 6. It's 4. So instead of 2/3 there, it's going to be 4. And then what's 6 times -1/2? Well, I don't know, Mr. Isbell. I'm not a math person. But I got a calculator, and it's pretty good at this stuff. 6 times -1/2 is -3. So that's really -3x. What's 6 times 7/3? What the heck is 7/3? It's a fraction. It's 2 1/3, really, if you want to get technical about it. But 6 times that is going to give me 14. Now look at that problem. Are there any fractions in it now? No. Okay? Here's what can blow your mind. When we solve this problem with no fractions in it, it's got the same answer as that one that had all the fractions in it. The reason that's legal to do is because I multiply both sides by the 6. In solving equations, if you've got an equal sign in there and you do something to this side and this side, it doesn't matter if it's wrong, if it's not the right move, as long as you did it to both sides, it's technically legal to do. Okay? So I multiply the whole problem, left side, 4 minus 3x, right side, 14. I multiplied both sides by 6. What that does is gets rid of the fractions. That 6 is a number that the denominators will both go into. We'll do another one, fractions in a minute. It's got different numbers, so we look at this again. Okay? Now, this is less intimidating of a problem than the first one, right? How do we solve this one? Okay, so if I subtract 4, I got negative 3x is equal to 10, and divide by negative 3. I ended up, does 3 go into 10 evenly? No. Is there anything that goes into both 10 and 3? Nothing other than 1, and 1 doesn't help us. So we're going to leave it that fraction, negative 10 over 3. Just like that. Yeah. Either I'll usually will put that at the top or out in the front. I hardly ever will leave it in the denominator. Excuse me, sorry. Felt it coming and just didn't stop it. Let's look at another one with fractions. 2/5 x plus 4/5 minus 1/3 x equals 7/8. So this one's got several different numbers in there in the denominator. This can be worked with the fractions in it, but nobody likes doing it that way. And it works the same if we take them out. So here's what we got to look at. Look at the what of the fractions. Bottom part, that denominator. So the numbers are 5, 5, 3, and 8. So we need a number that all of those will go into even. Well, 5 and 3 is doable. That'd be 15, right? But 8 doesn't go into 15. Okay, so it's got to be bigger than that. Let's think about things 8 goes into. 40. Does 3 go into 40? No. Let's see. 48. 3 goes into 48, but 5 doesn't. That doesn't work. 80. No, 3 doesn't go into 80. That doesn't work. 8 times 12 would be 96. 5 doesn't go into that. What about 8 times 15? What's 8 times 15? You can use your calculator. Nobody's stopping. So 120 is a number that 5, 3, and 8 all go into. So I'm going to multiply both sides or the whole problem by 120. Okay? So I'm taking 120 times 2/5. I got 48x. 120 times 4/5. 96. 120 times negative 1/3. Negative 40. 120 times 7/8. 105. 150, 105. Now, those are fairly large numbers, but they're not fractions. We can deal with that, right? That makes it a little bit easier on us. Okay? Now, I look at the left side, it's got 3 things on it. Can I put 2 of them together? Yes, 48x and negative 40x together would be 8x. So we have really 8x plus 96 equals 105. Well, that's not too bad. What do I do to get x by itself now? Subtract 96 minus 96. $1.05 minus 96 cents is 9 cents left. One more step. Divide by 8. And does 8 go into 9 evenly? No. So we're going to leave it that improper fraction. I may not be able to tell. That's Tennessee orange up there. We did the last step in Tennessee orange so that they would have done something right this week. I watched the game Saturday. It was awful. It's the worst. We're horrible. We're horrible. Horrible. I got to have some fun with this stuff. All right, so let's throw some of that distributed property back in there. Now, look at another interesting thing that happens with equations sometimes. All right, so this has got a lot of stuff going on. What should be our first step? Yeah, distributive property there, because anytime you see parentheses in a problem, you want to start there. Because order of operations says parentheses comes first. So distribute that -2. You get -2x minus 8 plus 3x equals x minus 8. Okay. Now, left side's got 3 things, right side's got 2 things. The song we used to sing on the Sesame Street, one of these things, it's not like the other. One of these things. Can you find that thing before I finish the song? What goes together up there? The 2x and the negative 2x and the positive 3x. So when I put those together, what do I get? I get x minus 8. And I get x minus 8 on the other side. That's weird looking. They're identical, aren't they? All right. If I move stuff, if I move the x's, what happens to them? They cancel out on both sides, no matter which one I move. And I get -8 is equal to -8. Is -8 always the same as -8? They're always the same number, aren't they? That's a true statement. It was technically true here as well. Sometimes we don't recognize it there, and it's harder to think because you got a variable. But here we get the same, we get an identical statement on each side. That's what's called an identity. Identity. What it means is the answers are all real numbers. It's an identity because it's identical on each side. And any real number that I pick will work for x in this problem. Okay? That's what that means. That only happens if it's identical on each side. Okay? Identity, the answers are all real numbers. That's an exceptional thing. Let's look at this one. 3 parentheses 3x minus 1 equals 9x plus 7. What should be our first step for this problem? Distributing the 3. 9x minus 3 equals 9x plus 7. That looks a lot like what we just did, but not quite. If we go ahead and do the x's thing, get the x's together, how do I move the 9x? Subtract it, right? Because it's positive 9x, and they both cancel out. Does negative 3 ever equal 7? No, negative $3 in your checking account is nowhere near the same thing as $7 in your checking account. One costs you money, one you have money. Okay? This is not true. This is false. That means it's not identical. It's a contradiction. It's a contradiction. It means there's no solution. There are a couple of shortcut symbols for no solution. One of them is the curly braces that have nothing in between them. They're empty. Another one is a circle with a slash through it. Be able to recognize any of those 3. These all 3 mean the same thing. No solution, empty braces, or a circle with a slash through it. All mean no solution. No solution happens when the x's are the same, but the other number is not. If you go ahead and move the x's, you'll get a really clear look at, hey, negative 3 never equals 7. So that's a contradiction to what that's talking. It means there's no solution. Okay? So know those words, identity and contradiction. Know that contradiction means no solution. These 3 things could be the answer choices. Identity is going to be all real numbers is the solution set. So there's a couple of exceptional things. The work is all the same, but the ending result is what's different. Okay? All right, still in this first section. Got 1, 2, 3, 4 more examples in the first section. Literal equations. Literal equations means we're not going to get x equals a number. We're going to get another equation as the answer. We're going to solve for a given variable. There may be more than one variable in the problem. For example, that's the right letter. J, yeah. 3x plus y is equal to 7. And they want us to solve for y. Solve that for y. So that means get y by itself. That's what they're telling us to do. Okay. What on the side that y is on is not a y? 3x. 3x. How do I get rid of the 3x? Subtract it because it's a positive 3x, right? Seven is a plain number. 3x is a number with a variable. They're not like terms, so you can't really put them together. You can just write it like that. Or if you wrote negative 3x plus 7, those are both correct. That one is what we call slope intercept form. The other one is just it's got y by itself. Form name. This is kind of how we'll do it next week when we start writing equations. So, it's all for the given variable. Let's do another one. Let's do one that's got a little bit more work to it. All right. 5x plus 4y is equal to negative 16. And I want to solve this for y. What would be our first step? Okay, how do I do that? Subtract 5x because it's a positive 5x. I'm going to subtract it. So that's going to give me 4y is equal to negative 5x minus 16. Or you could do negative 16 minus 5x. It doesn't matter. I'm going ahead and writing it that way because that's what we're going to have to do later on anyway. So I'm just going to write it that way. Now what? Divide by 4. What gets divided by 4? Everything. Well, these cancel out. Does 4 go into negative 5 evenly? No, so we're going to leave it negative 5 over 4x. Does 4 go into negative 16 evenly? Yeah. There is one correct answer. Another way to write that would be negative 4 minus 5 over 4x. This would technically be correct as well. Here's the one that can throw you a little bit, though. This is also correct. Negative 5x minus 16 all over 4 like that. That's also correct. Technically, is that the same thing as doing this? Technically, yes, it is. And the reason sometimes that they leave it like this is because the 4 doesn't go into both of them. So they're saying, oh, if it doesn't go into both of them, I'm not going to do anything with it. Okay, sometimes they leave it that way. Sometimes they go ahead and divide it out. Be aware that that can happen. That you could leave it like that or do this. Both of those things are legal to do. If this were like 6x minus 16 and you had a 2 on the bottom, 2 goes into both of them. They never leave that like that. They'll go ahead and divide it because it goes into both of them. Our textbook and the software that I use to make those online quizzes, sometimes if it doesn't go into both of them, it won't split it apart and just do part of it. It's technically, mathematically, that's still true. Okay. All right. Let's look at another one that's maybe a geometry type formula. Volume equals length times width times height. And we want to solve that thing for W. What's going on between the length, the width, and the height in the volume formula? They're multiplying. So to undo that, we're going to do what? All right, we want to leave W there. So what do we divide by? We got to divide by L and H, both of them. L and H. On this side, the L cancels the L, the H cancels the H. On the right, that right side, we got W left. The left side is volume divided by length times height. Nary a number in that problem. But mathematically, it's doable. Here's another geometry formula. P equals 2 parentheses L plus W. We want to solve that for W. What's that the formula for? Does anybody know? That again? Perimeter. Perimeter of what? Square, rectangle, rhombus, any of those things. Rectangle or square, either way. Squares are rectangles, but not all rectangles are squares. This works for rectangles, squares, rhombus. Doesn't matter. As long as it's got straight sides, this works. And 4 of them that are equal lengths in pairs. We want to solve that for W. There's several ways to get there. I'll give you an idea about the way you want to. What would you do to get W by itself? You could. That's not. You don't have to, but I think that's a good way to start. So if we distribute the 2L plus 2W, there's perimeter still by itself over there. Now, which one of those has to move? The 2L, right? How do I move 2L? Subtract, yeah. So that's perimeter minus 2 times the length equals 2 times the width. One more move. Divide everybody by 2. That's right. 2. There's W by itself. Perimeter divided by 2. What about 2L divided by 2? What happens there? What happens to the 2? The 2's will cancel each other out, right? Just got 1L or plain L. Either of those would be fine. And there we have W by itself. We've solved that for the width of that. Now, that's section 1. Let's do some application problems. Do a couple of those for this. This is section 1.2. Application of linear equations. Okay. Start with example A. The perimeter of a rectangular case is 40 inches. Write it out. The length is 5 more than width. Find the dimensions of the case. So here we have a word problem where someone's having more trouble. We just gave you the equation and then you can solve it. That's not a problem. Getting that out of the word problem sometimes it's difficult. So here's what we need to do. We need to break it down a little bit. So it tells us the perimeter of a rectangular case is 40 inches. So it says perimeter. Anytime I see perimeter of something that's a rectangle, I automatically think this formula. Or this one. I'll be honest, I think this one first. It's already distributed. I like that. Okay. It told me that the perimeter is how much? 40 inches. So that means the perimeter, P, is 40 inches. So that tells me that this problem, 2L plus 2W, is equal to 40. That's what this tells me. That first statement says the perimeter is 40. Well, we know this is how you find perimeter of a rectangle, right? 2L plus 2W. Okay, so that's what the first sentence said. The second sentence says the length is 5 more than the width. The length is, anytime you see that, something is this. That means it's equal to that. Is equal. The length is 5 more than the width. So mathematically, what's 5 more than? 5 plus. Or W plus 5 would be 5 more than the width would be a good way to say that. The length is 5 more than the width. if L is equal to this, and we got this big old formula here, it's got an L in it. Can I replace that L with this? That's what I'm going to do. Take that W plus 5 and put it in the place of L. 2 parentheses W plus 5. That's 2W. All that's still equal to 40. Now, how many variables do I have in this problem? How many kinds of variables? I got a W here and a W here, right? So it's only the one kind of variable. They're in two different places, but I got just W's. What do I do to solve that for W? There you go. Now what? All right, so 2W and 2W, 4W plus 10. Now what? Subtract 10, good. Because I'm getting like terms together. 40 and 10 were like terms, so that's 30 is equal to 4W. Last step. Divide by 4. I'm going to go ahead and convert it into a decimal, 7.5, since it terminates there. It doesn't go evenly. It goes 7 times, 2 left over, and 2 out of 4 is half. 7.5 inches. That is what dimension of this rectangular case? The width. How do I find the length? Add 5 to that, because remember it said the length is 5 more than the width. So the length, 12.5 inches. Width, 7.5 inches. There's my dimensions, length and width. In that particular case. All right. Perimeter problem. Not terribly difficult. That kind of process. All right. Does anybody remember ever seeing this? Distance equals rate times time, or the formula D equals RT. Remember that from math class along the way somewhere. If you don't, it's not a terribly difficult equation. Distance is equal to rate times time. That's all that means. Okay, D equals RT. All right, so we're going to use that for our next application problem. Bill and Ted are traveling on an excellent adventure. The trip takes 2 hours for Bill and 2.5 hours for Ted. Ted lives 40 miles farther away. Bill and Ted. Anybody recognize? Maybe too old. You do? Okay. No, they're not. Same actors? Oh, man. Bill and Ted are in the nursing home? Is that what it is? I forget Keanu Reeves is extremely young in that movie. So, trip takes 2 hours for Bill, 2.5 hours for Ted, because Ted lives 40 miles further away. Okay? Then we know this. Ted travels 5 miles per hour faster than Bill. We want to find each person's average rate of speed. Ted travels faster. He's not as worried about getting a ticket. Bill has some points on his license. Now, here's what we got that can help us with this problem. We know that if we're dealing with distance, rates, and hours, that's a distance equals rate times time idea. Okay, so if you see those things in a problem, you know D equals RT is where you're going to start. Okay, now, since we have two people here, I'm going to show you kind of a method for helping you set up a problem like this. And that method is using a table. So I'm going to set up a little table here. I'm going to have a Bill row and a Ted row. I'm going to have 3 columns. A distance column, a rate column, and a time column. I put them in that order just randomly. It really doesn't matter. Okay? Now, we know that Ted travels how much faster than Bill? All right, so whatever rate Bill is at, Ted is plus 5 to that. So if Bill is at X, then Ted would be at X plus 5. We don't know either of their rates. We just know that Ted went 5 miles an hour faster. That's what we know in this situation. Okay. What do we know about the time that it took Bill to get there? It took 2 hours. What do we know about the time it took Ted to get there? 2.5 hours. Even though he was he was going 5 miles an hour faster, it still took him 2.5 more hours. Okay. Now, here's where the D equals RT comes in. Bill's distance should equal 2 times X, right? Because it's distance equals rate times time. Ted's distance should equal 2.5 times the rate, which is X plus 5. Bill and Ted ended up at the same place. Okay? They're at the same destination. So Ted has got to equal Bill, but what do we know about Ted's travel? It's more than Bill's. Ted would be Bill plus 40, right? So we can set this problem up. 2.5 parentheses X plus 5 is equal to Bill's distance was 2X. But remember, Ted went further. So the plus 40 comes back. Ted went 40 miles further than Bill did. So Ted was equal to Bill plus 40. Bill's distance plus 40. This is Bill's distance, the 2X. The plus 40 was the extra mileage that Ted had to do to equal it out. This is Ted's distance. 2.5 hours times whatever Bill's speed was plus 5 miles an hour. Okay? From there, we solve that equation. How would you solve that equation? Yep, 2.5x plus 12.5, 2.5 times 5. And then we got 2x plus 40. What do we do next? That'll work. That's going to be 0.5x plus 12.5 is equal to 40. Now what? Subtract 12.5, good. $27.5, right? Divide by the 0.5. It's going to double that to 55. What does x tell us? All that work, we got to know what x is. For who? Bill is 55 miles per hour. Ted is how much? 60 miles per hour. That's what we're finding. Yeah, we're going to practice with those. Setup is going to be the same. There's not going to be many of those, but just be aware. I like the perimeter problems better than him. What I'm saying. All right. Last section of the night. I'm going to use some graph paper, but I'm also going to be graphing with the calculator as well. So I'm going to be bouncing back and forth here with this. If you got graph paper, great. If you don't, it's okay. No big deal. You'll still be able to see it on the screen. All right. Section 2.4. So we were in chapter 1 for the first couple of sections. We're going to jump to chapter 2 for this section, and then next week we'll have one more section after chapter 2, and then we'll jump back into chapter 1 again and get something pretty easy next week too. So we're going to talk about linear functions to finish up tonight. Okay? Linear functions different from linear equations in that we're going to have x and y both in the problem. Okay, it's a linear function. So f of x equals mx plus b. The m is the slope. Another name for that is rate of change. You may see that, hear that as we go along here. Rate of change, slope, they are the same thing. The b is your y-intercept, where it crosses the y-axis. Okay, that's what the y-intercept is. Where the line crosses the y-axis. Linear functions, we're talking about straight lines. No curves. We'll get to that after fall break. Okay? Straight lines here. Straight lines. Okay? The y-axis. Y-axis. Let's get an example. We're going to graph it, identify the slope, the y-intercept, and we'll talk about domain and range a little bit with this stuff too. f of x equals negative 2x plus 6. Remember, f of x, just another way of writing y. Y equals negative 2x plus 6. That's just another way of writing y. It's the function notation for that. Okay, so what we're going to do, I'm going to graph this by hand. I'm going to show you how to graph it with the calculator as well. So, coordinate plane, you got a y-axis, that's the one that goes up and down, and an x-axis, one that goes left to right. The way that you graph this is you start with your y-intercept. Okay? So we're going to identify the slope and the y-intercept. The slope is the number that's in front of x. So the slope for this problem is negative 2. The y-intercept is the number that's hanging out on the end, plus 6. So the y-intercept is at positive 6. Its ordered pair is 0, positive 6. So what that means is I'm going to go to positive 6 on the y-axis. 1, 2, 3, 4, 5, 6. I'm going to put a dot. And then I'm going to count my slope. And the way slope works is rise over run. So it's like a fraction. How do I write negative 2 as a fraction? I put it over what? 1. Anytime I've got a whole number or an integer, I can change it into a fraction by just putting it over 1. Okay? So my slope is negative 2, but we really want to think of it as negative 2 over 1. So the rise over run is negative 2 over 1. So negative, when you're thinking up and down, would be which one? Up or down? I'm thinking negative and down. So I'm going to start at this y-intercept. I'm going to go down 2. 1, 2. Then I'm going to go over 1. Go to the right. 1. Okay. And dot right there. Down 2, over 1. It's a 1 because the only way to write negative 2 is a fraction, or the easiest way to write negative 2 is a fraction. Put it over 1. Okay. There's me a second dot. I could do the same thing from that dot. I could go down 2 over 1. I could do that forever if I wanted to. A couple of times is enough. Gets me a good straight line. Then I would connect those 2 dots or 3 dots with a straight line. That's what the graph of that should look like. Okay? With the calculator, I hit y equals, and then I type in the equation, negative 2x plus 6. Negative 2, the x is up here beside the green alpha button. Right there, it's highlighted now. That's supposed to be red. So there's where you get x. Hit that button right there. And then plus 6. Plus 6. Then I hit graph. There's that line. That's the way the calculator drew it. That's the way I drew it. The same, don't they? Okay. Nice. Tick marks. 1, 2, 3, 4. 1, 2, 3, 6. And then going down 2 over 1. There. I'm right there on the blue line. And the little line. Keep doing that forever. Okay. So the graphing calculator can draw that graph for you. You've got to be able to recognize the y-intercept and the slope. The domain and the range for that. The domain is from negative infinity to positive infinity. The range is the same because this thing, it's more straight up and down, but it's still going to the left. This arrow keeps going that way. This one's still going this way, and it's still moving to the right. So the domain goes from negative infinity to positive infinity. The range, it's going all the way up, it's going all the way down. So the range is from negative infinity to positive infinity as well in this linear function that has a slope and a y-intercept. Okay. We're going to do a few more of these and kind of show you maybe some more of this stuff. And it'll start catching a little bit more. Here's another function, g of x, 3/4 x minus 5. Again, we want to tell the slope and tell the y-intercept. What's the slope? 3/4. Rise over run, 3/4. It's a positive 3/4. So we're going to go up 3, right 4. Up 3, right 4. Okay, because it's a positive slope. The y-intercept for this one, the ordered pair would be 0, -5. Draw myself a little coordinate plane here. We'll graph it with the calculator as well. The x-axis and the y-axis. What's the first dot that I would put? -5. The y-intercept is going to be the first dot you put, always. So -5, I'm going to -5 on the y-axis. 1, 2, 3, 4, 5, right there. I'm going to put my first dot. 1, 2, 3, 4, 5. Then I'm going to count my slope, rise over run. It's positive 3/4. So I'm going to go up 3 because it's positive. So I'm going up 3/4. Up 3, 1, 2, 3, over 4. 1, 2, 3, 4. And my next stop will be right there. Up 1, 2, 3, over 4. 1, 2, 3, 4. My next dot is right there. So that's how I'm counting. Rise first, up 3 because it's positive. If it had been -3/4, I'd have went down 3, right 4. It's positive, so I went up 3. I could do that again if I wanted to. Up 3/4. And there we have our line. I want to see that line with the graphing calculator, which is probably the handiest thing you could do. I'd go to y equals. I'm going to clear out that one, and I'm putting 3/4. If you just put 3 divided by 4, that's 3/4. X minus 5. Notice it's crossing. 1, 2, 3, 4, 5. That's -5. Up 3, 1, 2, 3, over 4. 1, 2, 3, 4. And I land right on the blue line. Same pictures, just calculator doing it for us. Okay. Slope, y-intercept. Start with your y-intercept, and then count your rise over run for your slope. You're gonna get plenty of practice with the rise over run in the this week and next week. Okay. F of x is equal to, let's do -x plus 2. Help you a little bit. What's our slope? Try again. -1. There's a negative in front of that x, so our slope is -1. Our y-intercept would be 0, 2. Good job. Where do I put my first dot if I'm going to draw this by hand? All right, positive 2 of the y-axis, so that's right there. And now I count my slope. How do I write -1 as a fraction? Put it over 1. Rise over run. It's a negative, so which direction am I going? Down 1, right 1. Down 1, right 1. Down 1, right. Go. There's that nice pretty line. Didn't mention this on the other one. We'll talk about it on this one. Domain and range. Negative infinity to positive infinity. Same thing on the range for this one. Example B would have been exactly the same. Nothing's different about it. Anytime you got a linear function that's slanted like that, domain and range are going to be the same. Okay. Calculator, go to y equals -x plus 2. Looks a lot like the picture I drew. Did it right. All right, let's look at this one. F of x equals -3. Slope's always supposed to be in front of what? There's not an x in the problem. So no slope also could be called zero slope. It has a y-intercept of what, though? It's 0, -3. This is another way this problem could have been written. They won't ever write it this way. That right up there and this say the same things. 0x minus 3 says slope of 0, y-intercept of -3. Just like this does, except for they don't have the 0x in it. Now, this one is a linear function. I'm going to go to -3 on the y-axis. The slope is 0. So that means I rise how much? 0. Up 0 over 1, right? 0 divided by 1 is still 0? Okay, so I could go up 0 over 1. Up 0 over 1. Up 0 over 1. Up 0 over 1. It'll be a horizontal line flat across there. Anytime, and this is what, instead of doing that, all that, my granddaddy used to say malarkey about up 0 over 1. Just memorize. If it's f of x or y equals a number, it's going to be a horizontal line at that number on the y-axis. So this is y equals -3, or f of x equals -3. Go to -3, just draw a horizontal line. If it was y equals 7, you go to 7 on the y-axis and draw a horizontal line. Memorize that fact. Too much mess to think up 0 over 1. Up 0 over 1. I don't think it helps you. Memorize that it's a horizontal line. This one has a domain that's -infinity to positive infinity, but what's the range? The domain is going to be from -infinity to positive infinity. The range, what's the only y value that's getting used? -3. That's the only one that's getting used. None of the others are getting used. So just brackets around a -3. That's it for the range on this one. Your calculator can graph that if you're ever in doubt. There it is. Nice and pretty. These horizontal lines, beautiful. It cannot do this problem, though. This one has plain x is equal to 4. That's not even a function. It doesn't have f of x or g of x or anything like that. That means it's not a function. This one is special because it has what's called undefined slope. And it has no y-intercept. It's another one of those. You need to memorize the rule. If it's x equals a number, you're going to go to that number on the x-axis. 1, 2, 3, 4. Put a dot and draw a vertical line. Y equals a number is horizontal. Y equals horizontal. X equals vertical. For this one, what's the only x value that's being used? 4. What about the range? Negative infinity to positive infinity because it's going both directions, up and down. Memorize examples E and F, or D and E. Y equals number, horizontal line. X equals a number, vertical line. Y equals a number, horizontal line. X equals a number, vertical line. Okay? At those numbers on the axis. Okay? Memorize that fact. Okay? Left, 3x minus 7y equals 14. That's not even in the right form. But it's got x and y. Could I take this equation and solve it for y? And get it? That would get us in slope-intercept form if we did that. Okay? So how do I get y by itself? Yeah. So we're going to solve for y. That's what anytime we see that. So 3x minus 7y equals 14. And yes, we would subtract 3x to get it to the other side. There's negative 7y equals negative 3x plus 14. And this is where that putting that x part first comes back. Let's do it in the first section. What's the last step to get y by itself? What's going on between the negative 7 and the y? They're mashed together like that. They're multiplying, so we need to do division to get rid of that negative 7 to every piece in there. Okay? There's y by itself. Negative 3 divided by negative 7 doesn't simplify, but I'm going to leave it. Well, it doesn't simplify number-wise, but the negatives, negative divided by negative is always positive. So it's positive 3 over 7. I'm going to leave it as a fraction because remember we're talking about slope, and slope we want as a fraction anyway. And then positive 14 divided by negative 7, negative 2. So here we have slope-intercept form. Y equals mx plus b. So that tells us that the slope is what? 3 over 7. The y-intercept, 0, negative 2. We know this line is going to be vertical, horizontal, or slanted. Slanted. If it's slanted, what do we know about the domain and the range? Both of them, yeah. Negative infinity to positive infinity. The range, negative infinity to positive infinity. Okay? Where's the first dot I put when I go to draw that graph? -2 on the y-axis. So I'll go to -2. Put the dot. Then what? Up 3, right 7. Up 3, right 7. 1, 2, 3, 4, 5, 6, 7. There I get my line. I can graph that with the calculator. I want to check it. 3/7x minus 2 graph. It looks like the one I just drew. Handy to find. Okay. All right. Let's look at calculating slope. Not finding it from an equation, but calculating it from two ordered pairs. Slope is change in y over change in x. Your textbook would have this fancy little formula, delta y over delta x. But we know slope is rise over run. And somewhere along our mathematical journey of making it to here, we saw a formula where m is equal to y2 minus y1 over x2 minus x1. Oops. These are two ordered pairs. Subtract the y's on the top, and subtract the x's in the same order on the bottom. Okay. You don't necessarily always have to use the second one first, but whatever y value you use first, you got to use the x value that goes with it first. Two ordered pairs. We're going to use this formula to calculate our slope. That's what we're going to do next. The last thing we're doing tonight is finding slope given two ordered pairs. Okay. All right. So let's get an example of this. Later we on G. Thanks. Find the slope of a line between -4, 8 and 2, -3. If you write the slope formula as many times as I'm going to write it today, you'll have it memorized. You don't even have to work on memorizing. Okay? So I'm going to write the slope formula. M equals y2 minus y1 over x2 minus x1. You'll write it every time I write it. You'll have it memorized before you leave. You won't even have to look it up. You go do the practice. Okay? So I'm going to take that formula and I'm going to plug in the stuff that I know. I know I've got a y value of 8 and a y value of -3. It does not matter which one you start with. I'm going to start with 8. Okay? Because it's bigger. That's why. Doesn't matter, but I'm going to pick 8 because it's bigger. 8 minus the other y value. What's the other y value? -3. So we have 8 minus -3 on the top. On the bottom, since I started with 8, what x value do I have to start with? The -4. I have to start with that one because I started with 8. -2. Notice my ordered pairs vertically. -4, 8, 2, -3. Should be that every time. Then I'm just going to work that out. What is 8 minus -3? 11 on the bottom. -4 minus 2. -6. -11 over 6 is our slope. That doesn't reduce any. You can, if it will reduce, you need to. But we're going to leave it as a fraction. Don't change it to a decimal. Don't change it to a mixed number. The only time your slope should be a decimal is if you're dealing with a real world problem that might include money or something like hour, you get paid, $7.85 an hour or something like that. So your slope would be 7.85. That would be the only time you would have a decimal slope. If your ordered pairs had a decimal in them, then technically, yes, you could have a decimal for slope. We normally want slope to be a fraction, though, because it's right on the line. Let's do it again. Here's our two ordered pairs, 10, -6, and 5, 2. 10, -6, 5, 2. We'll find the slope. That's all we're doing. M equals y2 minus y1 over x2 minus x1. Which y value do you guys want to start with? All right, 2 is bigger than -6, so we can start with 2. That's fine. 2 minus -6. So that means I have to start with which x value? 5 minus 10. So 2 minus -6 becomes 8. 5 minus 10. -5. So it's -8/5. And all I'm doing there is just bringing the negative up out of the denominator, putting it out in front. Either put it out in the front or put it with the top number. You don't want to leave it with the bottom number. Okay. Put it out in front or put it with the top number. Five -3, 2 -3. Again, we're going to find the slope. y2 minus y1, x2 minus x1. Does it matter which y value I start with? No. -3 minus -3. They're both the same. So that means it doesn't matter on the bottom either. What's -3 minus -3? 0. 0. 5 minus 2 is 3. What's 0 divided by 3? 0. It has a 0 slope. What kind of line has a 0 slope? Horizontal or vertical? Horizontal has a 0 slope. So this, and if you plotted these 2 points on the coordinate plane, you'd see that they're side by side like that. 0 slope. The y values are the same. Still using the slope formula, it works out. But if you recognize that can help. 2, 7, and 2, -4. Slope formula, y2 minus y1 over x2 minus x1. Plug in your stuff. What y value do you want to start with? Okay, 7 minus -4 over 2 minus 2. That'd be 11 over 0. Undefined. Why is it undefined? What's the only undefined operation in mathematics? Dividing by what number? 0. And the way that I always remembered this when I learned this at an 8th grade algebra class, Miss Patricia Campbell was my teacher. Anybody knows Miss Patricia Campbell from school? Sweet lady, still teaches math there at Sharon Baptist Church at the Savannah Christian Academy. Teaches all the math there. Great lady. Good math teacher. She taught me this, and it's stuck with me ever since. 0 under the line is undefined. Taught me a lot of other mathematical things because I had in high school. It's small now, but it was really small then, back in the late 90s and early 2000s. And she was my math teacher from 8th grade through graduation. So I had the same math teacher the whole time. So there were a few other math teachers, but for some reason I ended up in her class every time. Just the way my schedule fell. 0 under the line is undefined. 0 when you're doing slope. 0 on the bottom is undefined. 0 under the line is undefined. You and you. I hope you remember those. Okay. Being able to do slope, we're going to use that next week when we start writing equations of lines. So make sure that you kind of catch on to that this week as you're practicing and doing that Canvas quiz. And these, again, these page numbers are from the older version, but I don't think it's much difference. It's that section 1.1 and 1.2, whatever page those are on. These should give you a good smattering of what you could, encounter ones and odd on all those. This is 9 through 25. That's what that should be. I always recommend odd. Evens are possible, but odds, you got the answers in the back. Okay? So this week you got a Canvas quiz over this stuff. And next week we'll come in, we'll do labs over these 3 sections, and then we'll do the lecture for the next 2 sections. And that'll set us up for labs and a test on October the 8th, which is the week before fall break. Okay, so already fall break time, almost, seems like. So appreciate your time tonight. You are free to go. It is 7:15.